right. Hey, everybody. It is the 30th of March, 2023, and this is Plutus PBL live coding from Gimbal Labs and Friends. We're going to talk about a couple different things today, but Dan, you had an important question right before we went live. Do you want to bring that one back to us?
Yeah, will do. I opened up Demeter Run and set up a medium-sized work environment. Ran Cabal update, that was fine. Ran Cabal REPL and it failed due to a memory issue. And I thought, strange. Okay, reran it, failed again, reran it, failed again. I think it was the fourth time. Each time it was going a little bit further. So I think it was just using lots of memory up and not clearing the rubbish out of the way to do the new stuff. I don't know if that was what was happening, but it took several attempts to get it to actually run. And then it loaded everything and it worked fine. Yeah. So that was the question. Any pointers on why that's happening?
Yeah, and I think we've had some other people here with the same problem. Anybody else? Right. I think this has been a common experience. And so Juan was able to set up a meeting for him and me and Santiago and Fede, the leaders of TX Pipe and Demeter Run. And they were incredibly responsive. And that was one of the questions I asked them was, hey, why is this resource issue happening? And Santiago said that it totally makes sense because like we saw yesterday, we looked at on Newman's computer and on Vincent's computer, setting up your local dev environment for the first time. When you open up Plutus apps or when you run Cabal REPL for the first time, a lot of packages are downloaded and it can be really resource intensive to get that thing up and running for the first time. And that's why it's crashing on the smaller Demeter instances. Okay, it's the weight of the install itself is crashing the thing. So they have an answer to that. Santiago was able, I think just today, to add to the built-in Demeter caches, some pre-built files that will help all of us get started faster whenever we run the Plutus template in Demeter. So I want to apologize to everybody who had to deal with that the first time, but moving forward, I think we're in a much better position. And let me know if it keeps happening. But I think we're in much better shape. And thanks to Santiago. Going beyond that, the Demeter team is really interested in supporting Plutus PBL learners. And so we've got these contributor tokens that are being minted in the course and kind of as an embedded project that all of us are going to be able to see developing in real time. We're going to look at ways to use these contributor tokens to make sure that students, as they make progress through the course, can get some additional DCUs on Demeter. Okay, and so we're going to build out a proof of concept that we think applies to other scenarios where people working through this process will then get access to this technical resource. So really excited to roll that out more. And you've all already got the token in your hands, and now we're getting into ways to use it in modules 102 and beyond, because where this thing is going is this kind of real functionality. So yeah, excited to share those updates. Dan, I hope that makes sense, but it does sound like you got it running. And yeah, a lot more to come from the collaboration between this course and the Demeter team.
Yeah, it's fine. As I say, eventually it ran. Obviously it was building stuff, crashing, but the stuff it had built was still there, so it needed less memory the next time until it finally
exactly
sorted itself. Yeah.
And everything that was built the previous time around was still there. You can kind of see how that NICS storage works, or in this case, I guess it's not using NICS directly on Demeter. But you can see, right, when those packages come down, now they're set up and it doesn't have to happen again.
Yeah.
Awesome. So I wanted to jump in with this question first, and we could take this as far as we want to today. So I just wanted to share a couple of notes about transaction building, especially when it comes to interacting with contracts. And I have a couple of things prepared, but it's likely that this could shoot us off in any number of directions. So please, please, please interrupt me anytime. Just jump in if a new question comes up, or if you have like this, hey, what if this, what if that kind of thing in your head. But I want to start from the what if that Martin brought to us at the end of yesterday's live coding session. Right here in my terminal, maybe you saw this in module, can I make this a little bit bigger? Search. You might have seen this already in module 102, but if you haven't yet, we're just starting to interact with some contracts here. And people had a chance to interact with any of the three Plutus scripts that were built in module 101. So let's just say, I'm going to use the Plutus TX one, but I could do this with the Aiken or the PluTS as well. I can set as a variable in my terminal, whatever I want. I usually wouldn't write a variable name this long because it's annoying to write that, but at least it's very descriptive for right now. So I'm sticking with it. And then I can, and then I can query, woo, all right. I can query that address like this. And if you've done this before, you can see that at this always succeeds address, there's a whole bunch of UTXOs here, lots of them. And if you searched for this address, once again, this address right here, if you were to search for this address on preprod.cardanoscan.com, you would actually see that all of these Lovelace amounts add up to whatever amount CardanoScan is reporting right there. And you would see a record of all these other tokens in these UTXOs. Martin.
Like if I see the address, and this is always the same address, right? If you ask for an address for a UTXO or for a Plutus script,
Yes.
It will always generate the same address for everybody, everywhere?
That is correct. Yes, and that's a very, very important point. This was I want the Plutus template. And I have this output directory right now. Okay. So in the Plutus template, the first time you go through in module 101, you see that at the end of the day, we get this CBOR output. And this is the critical piece right here. As long as the contract compiles down to this, it'll always generate the same address on chain. Cardano CLI, address build. I specify which network I want an address for. And a payment script file. And I feed it this always succeeds.plutus. And I get, sorry about my line right there. I get this address right here, which is the one we were just looking at. Okay. And yeah, that's going to happen every time. If I change the network, I'll get a different address, but that's because it's a different network. Notice that I can use the exact same file right here and get a mainnet always succeeds address as well. I can't query this address right now because I don't have a mainnet node running, but you could search for this. Actually, let's go search for this address on CardanoScan. Copy it. Do you expect to see a lot of tokens at always succeeds on mainnet?
Oh gosh, did James cut out?
Yeah, looks like it.
Oh. Hmm. Yeah, like it was a little suspenseful. Just sort of yeah, he cut out.
Hey, sorry. Can you hear me?
Yeah, now I got you.
Yeah, I'm sorry. I don't know where you lost me, but it was when my internet stopped when I searched Cardano scan.
They can't stop stress, man.
Thank you. Well,
That's
check
a point of failure.
here's always succeeds on mainnet, by the way. There's 2 ADA there.
Nice. And
But now I'm gonna go over to Cardano scan pre-prod like I suggested a moment ago, and I'm gonna search the testnet address. And we will see that people are rational actors. There's a lot more test tokens at Always Succeeds on pre-prod than there are on mainnet, including some other tokens that people have thrown in here. So you can see this contract address has a long history, 709 transactions, and it has, like we looked at a moment ago, a lot of different UTXOs locked in it right now. Now, if we look closely, there is a difference between some of these UTXOs in the way that datum is handled on each. This one doesn't have any datum. And still, as far as I know, that means there's not a way to unlock this thing. I know Mix has been working on it, but any progress on that?
Oh, for now, the protocol doesn't allow because of the Cardano CLI in the ledger. There is a validation. There is a function that needs 3 parameters, and without this parameter argument, it doesn't work at all. And one of them is datum. So yes, that function, if that function in Cardano CLI, which is a wrapper around that library for ledger, failed, so it won't create the transaction. And that function accepts the validator script, the whole contract, redeemer, and datum.
Right. And right, so if you don't provide datum, the function is currently not built to be able to return successfully. Now, even when there is datum, it might come in 2 different forms. What I notice right here in this first UTXO is that it has a TX out datum hash and then a hash right here. While others of these have, for example, TX out datum inline. And you know, there's a lot more here, but this is kind of readable. I can see some recognizable information in this datum right here, which I can't see right here. And that's a critical point, right? This is the difference between hashed datum on chain and inline datum, which is just viewable to anybody. When you see this for the first time in the course, over in lesson 102.4, we're just using inline datum and not really talking about this yet. Okay, so now is the first chance for us to look at this together. But using inline datum is not the only option.
By the way, I remember something. There is a proposal for SIP called Deadman UTXO. There is a work for spending and bringing this get UTXO to the network again. But still, people are working and they are adopting the idea from Ergo. And the Ergo is like if the UTXO doesn't move for several years, it will be rewarded to miners. So here it will be rewarded or going back to the treasury, or some people can use it and spend it to themselves. So maybe that proposal. But again, it is possible if we change the protocol.
Right.
Now, no.
Right. And so like an advantage of an approach like that would be that maybe we can unlock trapped UTXOs at broken smart contracts. But a huge disadvantage is if you just want to hold tokens for a long time,
Yeah.
at some point you're going to have to move them just to keep them.
Yep. Bitcoin people doesn't like this at all.
I can imagine. All right. So we saw this first example with inline datum. And if I just type Cardano CLI transaction build, and I recommend doing this, don't be overwhelmed. There's an awful lot here that I can do with Cardano CLI transaction build. And like Mix is saying, this command is just an abstraction. It wraps a whole bunch of different functions inside of it that it's really, really good news that all these functions exist and are accessible. And by the way, right now, even as we're talking right here, Genius X released their Atlas PAB, which abstracts everything we are looking at right now, even another level. Okay, so they're presenting over at Emergo Academy right now. I'm excited to watch that video later. And together over the next few weeks, as we work through this course, to look at ways that Atlas might make these steps even easier. But I think just for getting started, it's still worth it to know what's possible here. And in particular, I want to look at our options for TX in. Right? We know that we can just use TX in with a simple transaction hash, a simple UTXO. However, anytime we are unlocking from a contract address, there's some other stuff we must supply in order to run that unlocking transaction. And this is where we're going to get to today. Before we do, I also want to look at TX out. When I make a TX out, I must specify an address and a value, right? That's required. I have the option, if I'm sending to a contract address, I must do this in order for these UTXOs to be unlockable, but I have the option of how to add that datum to a transaction. I could use a hash. I could use embedded CBOR or JSON files, or I could use inline datum. And when we queried always succeeds a moment ago, we saw examples of hashes and inline datum. And so I want to just take a quick look at that difference right now. Once again, this transaction right here will work with inline datum as that outbound datum option. And if you follow through with this approach, you'll just see the number directly on chain. And we'll look at another example of this in just a moment. But what I would rather do right now is try this approach. Let's hash the value when we lock a UTXO. And then let's see what it takes to unlock that thing and what kind of errors we might get. Any questions so far, just from this high level view?
Yeah, is it required a datum?
It is when you, okay, well, so two-part answer to that. When you lock a UTXO at a contract address, it's required to add datum to that UTXO. However, it is possible to send a transaction to a contract address with UTXOs that do not include datum. This is a danger, right? There's nothing when we build a transaction using, for example, Cardano CLI to prevent us from making this mistake. But if we make this mistake, the UTXOs that result from it will not be retrievable from a contract address.
Oops.
Right? Well, I mean, test nets, right? This is why we have test nets. And this is why, you know, as you start to build or use additional tooling, it's a really good idea to use tools that you're certain are not going to make this mistake. I see to grab a little scratch pad for myself over here. Let's do this. All right. Okay, so I need a couple of variables. First of all, then oh, it's called bash scripts. All right. There's a suggestion. Oh, and I haven't even set it up on this computer, right? These scripts are provided with the Plutus template, and there's a suggestion in the lesson notes to make a private variables file so these work even more easily, but we can come back to these another time. I was just looking to get those variables. Give me just a second here. Grab those. I'm just preparing a wallet for myself. I'm going to take this guy. I'm just going to call this my sender address. Right. So now every time I type $sign sender address, it represents that guy right there. And then this you should not do with mainnet keys. But just so you can see an example of the thing you shouldn't do, I'm going to do it for you. Here's a sender key, and I'm exposing the file path to that S key file or that signing key file. Okay. But now I'm able to use them and create this demo more efficiently. Mix. Hey, you're muted.
Sorry. Jean told me that Laris told about that it is like in recent changes. That's why actually I'm asking. In recent changes in mainnet, you cannot send a UTXO without datum to a smart contract.
Ooh.
Is it? I mean, does anyone try that in mainnet? I mean, it's
on mainnet.
Mainnet. It's like it
doesn't
allow you.
Let's see if I get an error from pre-prod right now. Let's just see.
No, pre-prod you can. I sent it. I think.
Oh, it does. Okay.
So I just.
Well,
it is a risky test.
Yeah, exactly. Who's going to spend the min UTXO to find out? Right? Where does that validation happen? Is it at build?
Even Janti told me. I mean, he told me months ago, but I haven't tested to be. I didn't say okay, never mind. I don't want to bet 2 ADA or 1 ADA to
Exactly.
test.
Yeah, get out of here. I'll let somebody else prove it.
Yeah,
Let's
make it bounty.
got the number one
We'll
here.
give you 2 ADA if you burn 2 ADA.
So I have a little wallet that I've been using to just try some stuff on pre-prod right here. And this is, not too messy. Looks like I've got 182 test ADA here. So that's going to be enough for everything I want to mess around with today. A couple of other UTXOs. And as you can see in this wallet, none of these UTXOs have datum. And that's not unusual, okay? So what I want to do is I want to use one of those UTXOs as my UTXO in, and I'm just going to use the biggest one because it's easy. I could probably get away with one of these smaller ones as well. And then I need the always succeeds address, but I think I already did that, right? Always succeeds. Yep, that address. And I'm just going to lock 3.5 ADA. Whoops. We'll call that Lovelace to lock. There we go. All right, but I can't quite just copy and paste this from the course documentation because I want to handle my datum differently this time. So let's take one more look at Cardano's CLI transaction build. And this time I want to include the TX out datum hash. But I'm still just gonna, in this case, I can still just supply a value. I'm still just gonna type the number 1618 this time. But because I'm gonna use TX out datum hash value, it's gonna hash that number for me. I could also hash it in advance and just attach the hash, which is incredibly valuable. If you are, for example, if you have some back-end service or otherwise some process for creating the datum that you want hashed and included as datum, you can construct all that datum, hash it, and then attach it to any transaction like this. So it's verifiable, but not just nakedly visible on chain, okay? So this is the only thing I'm going to change in the transaction I'm building right now from the course documentation. I should be able to, with these variables set, just grab this transaction build right here. And if it's successful, hopefully you've noticed this part in some of the documentation. I'll get this message that says estimated transaction fee. Once I have that, I can just sign and submit like this. And then I can wait to see it on chain. I don't know if I didn't really cover this in any of the lectures yet, but right here you can see an event on my node where the transaction I just submitted enters the mempool for my node. And we can watch as new blocks come in, and we can see a message when this transaction goes through. Let me query my address again. And we're going to see that this UTXO we were just using is no longer here after this transaction is on chain. Any questions or observations while we wait for that to happen? And don't worry too much about this part right here.
Yeah, I'm enjoying listening in. I mean, I understand that you're speaking English, but it's it's a lot of vocabulary and things that I'm that I just have a sort of secondary adjacent sort of understanding around. But I think I'm gonna step out now and then move on to the next one. I think I'm on 101.5. I can write always successful validator script in Aiken. And I'll be back next week and we'll keep going. I really appreciate you.
Rock and roll. Thanks, Newman. Appreciate you too.
All right, man. Ciao.
Still waiting on this guy.
Then do you want to decode the contract address very quickly so people
Yeah,
can
let's do that while we're waiting.
So the command is bec32. I think it is built in everyone of bec.
And I can decode straight from, you said, the contract address?
Yeah, bec 32 and the 3 arrow like this. That's in other direction. And then paste the address, the contract address.
Yeah. It's always.
So this is the contract hash. This is the hash of the file. So as long as you have this hash, you will end up with the same address. It's just encoded with a way to, make it better, like it's ADR and so on.
How would I use just this bec32 commands to encode a datum hash? Does that work? I mean, I know that I could use Cardano CLI to do that.
I think you can decode it for encoding. You need to follow the bec32 standard.
Okay. All right, we'll come back around to that.
Yeah.
You can see my transaction has been successful here because I can see from list, and now there's no transactions left in my mempool. So if I run this query again, I should see different UTXOs in this wallet. Now, most of them are unchanged. I didn't spend this one, so I can still see it right here. I didn't spend either of these, so I can still see those right here. But I spent this one, and I can't see it anymore. All right. And as output, I have, this new one that ends in FE66 that was not present up here. And this UTXO right here holds 178.6 ADA, a little less than the input UTXO held a few moments ago. But here's what's really important. This transaction hash right here, yes, it represents this UTXO in my wallet, but it also represents the transaction that just happened and also has other outputs. Look at this index right here. It's a 1. 1 is the second index in a list. It comes after 0. So where's the 0 index of this transaction? Anybody following along well enough to know the answer to that one? I built a transaction.
It's locked in the contract address now.
Exactly. This transaction I just built actually had 2 outputs. One right here that went to the contract address, and the other, this line right here, change address. It actually does create a UTXO, but it does some subtraction for me, right? It just gives me all the rest of the Lovelace that were left over after the transaction. So one output here, one output here. This change address, sender address is what results in this UTXO right here, the second output. Notice that it's listed second after the first one. And so let's go find that first output. Same query, but I'm going to use my contract address once again. And I'm looking for a UTXO that starts with 2341 in its transaction hash. And remember how I just locked 3.5 eta. I'm looking for the one with 3.5 eta in it that starts with 2341. Let's find it. It's still a long list, but that's part of the reason I use 3.5 eta is it'll help me just, I'm scrolling through the values right here, looking for mine. Where is it? There it is. And look at this transaction hash. It starts with 2341. Just the same exact transaction as we're seeing up here. Right? Two UTXOs that were output by the same transaction. And this is the one I just specified in my transaction build. Martin.
Yeah, I see sometimes you get a new UTXO and sometimes you get an index. Is that true or?
Yes, this is so important. All of the outputs from a transaction are going to have the same transaction hash. Because this is what a UTXO is, right? It's a transaction output. And so we want to say, okay, well, where did that UTXO come from? It always came from some prior transaction. And we can trace back. This is the blockchain part, right? The transaction record. You can trace all value backwards through transactions on chain by just following the transaction hashes of where inputs came from backwards in time. Augustine, what do you think?
I have a question regarding the part where it says hash datum value, and the value that is set is 1618.
Yes.
And supposedly the hash has to be longer, right? A hash value usually is like, so I'm confused.
Yeah.
About that.
Cool. And
it's probably because the smart contract doesn't care about what the input is. So you can put anything. That's my hypothesis so far, but I don't know.
Now, so this is exactly it. Okay. So, and this takes us finally to Martin's question, right? And you just said the most important part. The contract itself doesn't care what this number is. We wrote an always succeeds contract where it doesn't matter what the datum is. In fact, with the one we're using right now, it doesn't even have to be a number. It could be a string. It could be a huge piece of arbitrary data. And we see that down here. Like here's a big old chunk of arbitrary data. It could be anything. It's a big object, right? But when the datum is hashed like this, or like in the UTXO that we just produced right here, like this, even though it doesn't matter to the contract, when I try to unlock a UTXO with hashed datum, I must provide an input value that results in this hash right here. Now remember this hash. It starts with 2DA1C, and we'll come back to it in just a second. One thing I can do, Cardano CLI transaction comes with a subcommand called hash script data. And it says that I can supply it with either a CBOR file, a data file, or a simple value. Well, this is what I did with that 1618 in my in my transaction build. Let's just do this. Script data value 1618. And lo and behold, what hash do I get? 2D A16C6. And that sounds familiar, right? This is exactly the hash we just saw in the UTXO that I just created. Harsha, what do you think?
So I had a question about something slightly before this. When you are querying the UTXOs from a wallet, how are the UTXOs ordered? Is it like most recent to like the first one, or is there something else?
Yeah, does anybody know the answer to that? I'm not sure, right? It's not quite even alphabetical. I see 2, 6, 8, D, E, but what's this 6, 1 doing there? So I'm not sure. Anybody know that one? Roberto.
I just have a question related to that. We're querying the node through the DB sync, right? So we are relying on DB sync's indexer to give us this information?
Oh, okay. In this case, I am just running these queries against a node that's already running on my computer.
James, that 6.1 is not a transaction hash. It's part of the datum.
Oh yeah, you're right. Nice, very good. Good answer. All right, so it looks, that makes a nice clean answer. It looks like these are ordered alphabetically by TX hash. That's satisfying. All right, so I can produce a hash that matches some datum if I know what the datum is. But to finally take us full circle, what would have to be true in order for me to be able to unlock, say, this UTXO right here? It's got a TX out datum hash that looks like this.
You should do it in reverse, but I'm not sure if you can.
Bingo, right? And so this is the case. There's not a computationally easy way to reverse this hash to its underlying data. And that's a good thing. Now, there is a brute force way just to create, just like searching passwords, right? To like make common datum and just map over them rapidly until you find the datum in question, the datum hash in question. And some Andrew Westberg, maybe a year ago or so, as some of this stuff was just getting started, made a pretty cool video where he was benchmarking, like, here's how long it would take me brute force to break your datum hash, right? I look up that video for fun. But for our purposes, we should not understand the datum hash as absolute privacy. All right. If you put 100,000 ADA in a contract address, and all that had to happen was somebody had to figure out the hash, somebody would figure out that hash, right? There's enough of an incentive to do whatever it takes to get that, okay? Don't think about your hash as privacy or security, but it can add a nice, it can at least add like an effective layer of privacy, right? From at least the casual observer. It can be easier to use if you have complex data structures on your back end that can be represented by a hash like this. You can build some reasonably secure systems, okay? But I just want to think about this distinction, right? Without knowing what data was used to produce this hash, I can't unlock this thing. And so here's the case of always succeeds, not succeeding. None of this is at the contract level. This is all at the protocol level, how data works. The contract doesn't care what this was, but still we have to be able to reproduce this hash in order to get it. How does everybody feel about that?
What is the reason? Do you know the reasoning behind why you would do this?
One is you just don't want people to be able to look directly at your data on chain. You want to at least put a little bit of a wall between what's visible publicly and what's actually on chain. This hash takes up less space on chain than a big chunk of inline datum, so it can be cost effective to use this approach. And then, yeah, I think a lot of times we're going to see a lot more examples over time of big chunks of data that, you know, it's not, privacy isn't the concern. It's not like we're trying to hide things from anybody, but it's just not, it's not efficient to put all of the data on chain, and just putting a hash on chain allows people to verify some truth. And think about governance, right? Something like this is used or will be used when a constitution is written. We're not going to place the entire Cardano constitution directly on chain, but hashes of that constitution will be placed on chain. So anybody who reads that document in some form will be able to hash it and confirm for themselves that the same hash results from that. Okay. We're using the same thing in Gimbal Project, Treasury, and Escrow, which is the DApp you'll start learning about next week. And if you've been here for prior iterations of the course, you've seen this. We can simply hash some details about a project, and we can put them on chain. Let's look at when it comes to unlocking this thing. Oops. Transaction bill. When I unlock a transaction, or sorry, a UTXO from a contract address, I have to talk about the Plutus script in one way or another. And what you saw in the course is that we are just attaching the script file itself, like this, txin script file. And I can just, right here, right, one way to interact with a contract is just by providing that .plutus file. Another way is to use what you might have heard of, these reference scripts, where it's possible to put a compiled Plutus script on chain. And we might have just enough time to look at that briefly today. If we don't, this is coming up real soon. And you'll actually see it you'll see this in use in assignment 102.2. So if you're curious what it looks like to use a reference script, there's a chance to see it there. But for now, I'm just going to use the file itself. And when it comes to datum, I can provide either the CBOR or the JSON value, or I can declare that inline datum is present. Notice that one of my options is not simply to include the hash. This is a key point, right? I can't, if I could just read the hash from on chain and I want to unlock a UTXO, part of me is like, well, what if I just attach the hash of the datum that I'm trying to unlock? No, not an option, not sufficient. You got to know the value, either the file or the JSON value that created that hash in the first place. So I'm going to build this transaction now. And I'm just using I'm using our notes. I need to set the path to a Plutus script file. And for me, this is going to be PBL 2023. Plutus. Oh no. PBL. I forget what it was called. 2023 Plutus template. And I want the one that is compile. Filed Plutus always succeeds Plutus TX. Sorry about that. I should have had that ready to go. So if I say Plutus script file now, this is the path to the Plutus file in question. Also new at this step is I need to provide a collateral UTXO. And this is covered in lesson 102.5. For now, I'm just going to specify one of my smaller UTXOs that doesn't have extra tokens in it. Like this one right here will do. And this one is not going to be spent in this transaction. It's just there for if I make a mistake, and it's the main purpose of collateral UTXOs is to prevent DDoS attacks or spamming the network. So I've got a collateral UTXO. I need a contract UTXO as well. So I need to identify the UTXO that I was trying to unlock in the first place. Let's find it again. Should have written this one down. Here it is. Okay. So I'm going to copy that with index 0, and I'm going to call that contract UTXO. Contract UTXO. And that was index 0 for this one. Okay. And then what we were provided in the course is this command right here. So let's take a look at this. Actually, let me grab the protocol params first. I'm pretty sure I haven't done that in this directory. Protocol parameters. Not the way I typically want to operate typing this by hand, but I hope this is just giving people a chance to think about these commands. All right, so now I've got some protocol params. That's good. All right, let's drop that transaction build in here again. Now, one thing you'll see. Oh, nice. Yeah, Martin, thank you. I'm still learning Bash myself, so grep, this is great. If I did a bar and then that, it would find that UTXO, right? And Jeff says collateral is needed because the scripts are Turing complete. We can't be sure they'll finish. That's part of it, and I'm not sure. I'm not sure how much that tells the whole story. But yeah, collateral, there's some details, right? This is one of those places where you can kind of go as far as you want down into the protocol level details of how collateral works and what are the rules for how it could be forfeited. Now this transaction build right here is not going to work. And a quick note on trying things. I really like the Cardano CLI transaction build command just for finding out if my contracts work like I expected. And one of the things I like to do when I'm first sketching out how a contract might work is just have a couple of scripts ready that don't even try to sign and submit transactions, that are just going to build that transaction with different datum and different redeemer values in different ways, just to see if the guards I've written into my validator work as expected. This is what a PAB should do automatically for us. But sometimes when I'm just getting started, I even like to be just really hands-on with it and test a few things directly. That's what we're going to see right here. This transaction is not going to build. Why? Well, the UTXO we're trying to unlock doesn't have inline datum in it, so it can't work. But see what error message we get. It says the Plutus script witness has the wrong datum according to the UTXO. The expected datum value had this hash, which should look pretty familiar by now. That's good, okay? I just got always succeeds to fail by trying to unlock a UTXO and claiming that it had inline datum in it. Let's just change that line. What line was it again? It was TX in, and let me try supplying a datum value instead of claiming that inline datum is present. I said that value should be 1618. So over here off screen, I'm just typing it, TX in datum value. Okay. And let's bring that over to the terminal window. This one. This is the same exact transaction build as I used a moment ago, only this line right here is changed. Let's see if the build succeeds. How do you like that? Martin, what do you think?
With the inline datum present, so if you do inline datum, you don't have to supply a value if you want to unlock.
That's exactly right. And that's what we're going to do next.
Ah.
Okay. Right. I want to show you one more error. All right. So I just pressed the up arrow and I'm just going backwards through this command. I'm going to change that 1618 to a different number, like 10. And what do you think is going to happen? Wrong datum. According to the UTXO, the expected hash is this. It's just telling me, hey, you put this other number here, 10, didn't give us the hash we wanted. You put the correct value there, we're good. Build the transaction. But put an incorrect value that doesn't match the hash, you're not going to be able to build the transaction in the first place. And you can try this, right? You could look for, I bet if you hashed just the number 0, or if you hashed the string hello world, and you looked for that hash of the always succeeds address, you might find it, be able to unlock that one. For us, we're going to stick to this one, which builds. And now that it's built, I can sign and submit it. And it's submitted successfully. Questions about that? So this is not covered in the course yet, but we're just looking at how to unlock if we provide a hashed value. Harsha, what do you think?
So instead of the datum value, if you put in the hash, would it still work?
Excellent. So like right here, if I say I want to unlock this UTXO, here's the Plutus script. Can I put a hash right here?
Mm-hmm.
Right. So there's no commands provided for that, right? If I look just at Cardano CLI transaction build, and I look at all the options, the only options I see for the TX in unlocking are to supply the datum as a CBOR file, a JSON file, a value, or to declare it present, right? But I guess like one thing I could have done, and you should try this. I know the answer is no. Okay, try it for yourself though. Throw, instead of 1618, put the hash right there in place of the value. And what's going to happen at build time is that hash is going to be hashed, which is going to result in a different hash, and therefore it's not going to work. Okay, well, that's pretty nice. But let's now go take a look at one of these other UTXOs that has inline datum. Maybe this one right here. It's got all sorts of crazy stuff going on, and I want it. So let's get it. Here's what we're going to do. I'm just going to take this UTXO and I'm going to make it my contract UTXO now. That has index 0. So contract UTXO is this at index 0. All right, cool. I need to, oh, I already have my collateral, so I don't need to change that. And I want to show you this. Echo collateral UTXO was 8838 ending in #1. And if I query my sender address again, I'll actually see that I just got this new one right here with 3.32 ADA. That's new to me. And it's a little bit less than 3.5 because I didn't supply an additional UTXO for the fees. I just took the change. But you'll see that my collateral UTXO is still right here, unchanged. Right, so I can just keep using it. And so if I want to now unlock this other contract UTXO, which remember, it looks like this, I could just try to do it. And I can just declare that there's inline datum present, and that's all I got to provide. Now this is not going to work right away, but it's going to show us another pretty cool thing. Can anybody see by looking at this why it might not work? We're about to find out. Watch this. Ready? I'm going to build, whoops. I'm going to build this transaction right here. It looks just like before, same script file. We're still trying to unlock always succeeds. Inline datum is present now. Redeemer we haven't really talked about, but this number can just be whatever I want because the always succeeds validator says it could be whatever it wants. But this thing is going to fail and show us another pretty nice little opportunity. Notice it didn't fail because of datum this time. I got a different error. So it seems like, okay, the datum part seems to be working, but it says non-ADA assets are unbalanced. And did you notice in that UTXO a moment ago, there was more than just Lovelace? There was also 230 of these other tokens. What are these? I'm not sure. Should I try to take them anyway? I could. Let's go back, look at that UTXO, and we can see transaction hash and index. There's some value here. I see some Lovelace, but then there's 230 of this other token. And then there's the datum. So my value has more tokens in it. Let's just add those as a TX out. I'm just writing some notes here to kind of build as we go. So I'm building this transaction. And what I want to do is add another TX output to my sender address that includes, let's just say, some minimum amount of ADA, like 1.5 ADA, plus those 230 tokens, whatever they might be. Okay. And I'll need to put a slash. That slash is just so I can use the next line in a bash command. Notice there's not one at the end. Okay, so value in this TX out is all in quotation marks. There's the Lovelace and then the additional assets. We're going to look at this a lot more over the next few weeks. But I think if I build this transaction like this now, it should work. Oh, not enough. Lovelace. The net balance. I pull in, oh, let's see. That's a good one. The UTXO we're trying to spend, this one, has, that's got, oh no, here. Okay. Okay, the UTXO we're trying to spend has 1.586 ADA in it. What I just did in my transaction build is I tried to send 1.5 ADA and these tokens to my address. And then I tried to send some additional change to myself, and I had to pay the fee. And where was all that Lovelace going to come from? That took care of the fees and potentially change to myself. Well, how many inputs does this have? There's only one input in this transaction right here, and it's only got 1.5, almost, less than 1.6 ADA in it. That's not going to be sufficient. So here's a case where I'm getting this error. I wasn't short by much. To cover the transaction fee, I just need another basically 9 cents of an ADA, right? This is less than 1/10 of an ADA, but I don't have enough. And look, it tells me down to the Lovelace, down to 1/1,000,000th of an ADA, what the very least I could do is to get away with this. And I just haven't provided enough. So let me go back to my transaction build over here. And let me add another TX in between. And I've been using variables for TX-ins, but I don't have to, right? I could use a variable for an asset name to clean this up. That would be nice, right? But right here, just to show you, I'm going to go over to my wallet again, and I'm just going to grab another UTXO from my wallet and put it like this, all right? Could make a variable for this, but don't have to. And remember, now I have 2 TX-ins, one simple one from a wallet. Just specify it. To spend it, I got a sign. The other UTXO comes from a contract address. And I can't just write that by itself. I have to say, hey, it's from the address that goes with this Plutus script. I'm going to tell it about datum, tell it about redeemer, and tell it about, well, collateral is a different thing. But yeah, this is a chunk right here. Contract, script, datum, redeemer. Now let's put all that together. Same as before, just added a UTXO. No problem. Fee is a little bit higher than last time because there's some tokens involved. But still not much higher than the minimum. You're kind of familiar with the minimum of being a little bit less than 0.17 ADA maybe. All right, so this is 0.184 ADA. That's okay. I sign and submit. We're good to go. What the heck tokens did I just claim here? I don't really know. So what do you think? I'd love to see in the chat, like just on a 1 to 5 scale, like 5. Oh yeah, I followed along. Everything made sense today. And 1's being like, that was gibberish. I have no idea what you're talking about. I would love just to know where everybody's at. 3s and 4s are good. I'll take that.
The balancing of amounts sometimes could be a little bit tricky. But it's good, huh?
Couldn't agree more. And this is why, Sebastian, that's what's so critical about that point. That is why, number one, we wouldn't want to do it like this every time. And if you understand what Sebastian just said, right, the balancing of amounts, it's tricky. Is it hard? No, it's annoying. It takes time. I just got to look at all those numbers of, make sure it's all taken care of.
Yep.
If you understand that, that's why we are so excited about things like Mesh. It just does it for us, right? Not only does it do it for us, but we don't have to sit here in the terminal. We could write a little JavaScript to do it. I'm excited to review the new PAB that Genius is releasing today, right? It's gonna be a different option for making these steps less annoying, okay? So yeah, I want everybody to be like just annoyed enough at this process that you're really excited when we start using better tools, okay? And under the hood, I guarantee if you're able to think about transactions like this, it's going to make more sense as you start to build real applications, okay? So thanks for going on this journey with me today. And if you have like new wake up thoughts tomorrow, I would love to hear them. And just hear what new questions you have or insights that you're starting to have. Query my address one more time. Now I've got these tokens. I could take this token name over here. This is risky live demonstration. I'm going to decode this token name and find out what the heck I just grabbed here. There's a few different ways to do this. You could do it from the command line, but I think we've asked enough of everybody watching command line stuff today. So I'm just going to copy this. Whoops, just this bit right here. And I'm going to bring it over to a trusty website that I like called stringfunctions.com. There's a lot of different ways to do this. And I could just paste a hex string in here. Ooh, it's some deged test micro USD. That's pretty, okay, I'll take them. Right, and if I now go search for this address on Cardano scan, I'm going to grab my CLI address that I've been using for this demo today and head over to pre-prod Cardano scan, search for that address. And I can see, oh, it's just a fraction. I don't even have 230 of them. I've got a fraction because they're denominated in billionths. But there they are in my CLI wallet. Agustin, what do you think?
I have one problem with unlocking contracts, but it's a little off topic because it's about the Plutus Pioneer program. But man, I can unlock any smart contract of the course. So I wanted if consult none.
Damn.
And I hope I'll have the same problem. So I wanted to consult that at the end.
Yeah, let's do you have a link like to maybe the first one that you're struggling with, and we could just look at it real quick? I'll just open it on my screen.
Do you mean about the GitHub repo?
Yeah, like what lesson, or yeah, I can probably just search for it too, but what lesson was it?
Yes. Give me a moment.
Yeah. Week 4, homework 1. Okay, it provides this script, and what's the actual?
The script is good.
Right, the
but
off-chain code.
Because they say to you the homework is deploying the smart contract and unlocking it. The script is good. So from that side, I think it's okay. But maybe I'm doing something wrong with the Cardano CLI. I don't know. I always have the machine terminated because of an error, either from a built-in function or from an explicit use of error caused by built-in unconstruct data. I always have that same problem. I don't know how to.
Okay.
I consulted in the Cardano. Yes.
I know that error. And that error is going to happen when in our, you can see right here in the Plutus code, a data type is defined called mastery datum or mystery datum, and then it's used in the validator right here. And you're going to get that error in building a transaction when the datum you are providing doesn't match the datum that's expected in the Plutus code, right? So in the previous example, we weren't seeing that error because we make no claims about what the datum has to be. But this is a more advanced Plutus contract where we say exactly what the datum needs to be, and therefore we have to match that. We've got a lot of examples of this coming up. And would it be okay if we start with this question next Wednesday?
Okay, perfect.
But try to explore it on your own. Okay, see if you can figure it out, how to construct that datum. And if you're not able to do it, I got you next week. Okay, let's see.
Yes.
Let me give you some hints. We have, I believe, I don't think I've put any examples of this yet in the new repo, but I think, yeah, we got some. Here's an example. This is an example of what on-chain datum could look like. I'll put this link in the chat just so you can. For me, the hardest part of this was just familiarizing myself with the data structure. All right, so this is datum. And just to give you a little mystery to figure out on your own, I'm going to show you what this aligns to right here. So this is an example of what's called commitment escrow datum. And this was defined in an actual Plutus project over here as escrow datum. Okay, I'm going to drop this link in the chat as well. And I think you might be able to get this datum built if you take this as an example. Let's just take a look for a second, right? this datum has 5 fields inside of it, right? Just like this datum does right here. When I look at this datum, those fields are bytes, int, bytes. Let's see if that checks out in the example over here. Bytes, int, bytes. Bytes, a pub key hash is a byte string. Integer, int, that's good. Integer, good. POSIX time is actually just a wrapper for int as well. So we can use an int there. And then a byte string is a byte string. So bytes, int, bytes, just like we're seeing in the JSON format here. So this JSON right here would allow me to build a transaction that satisfies the constraint here when I interact with this contract. Yeah, okay, that looks good. Bytes, int. Bytes, int. Yeah, that looks good. So that's what you've been using, but it's been failing anyway?
Yeah, yes, this is, yes,
Yeah.
yes, I have.
Okay.
I tried to do it the date many times, but I don't know. I'm
Structure fields.
I'm doing the same
Some
steps of the tutorial, so I don't know.
Hmm. All right. Okay, so the other thing, as you were describing this, but the error you described, this doesn't make sense. The error you described makes me think about datum. And do you have the transaction you're actually using? Like, so you have this file here. What datum, what txin datum tag are you using to add it to the transaction?
Do you mean the index of the UTXO?
I mean, like this line right here. So in this example, when I was unlocking this contract UTXO, I said txin inline datum. But remember how there's other ways to say txin datum? What are you using? So after
Can't.
And just to show you, this is what you ought to be, maybe you already are, right? But this is what we want to use right here, txin datum file. And then you would have the path to the JSON file that has the contents that you just dropped into the chat right here.
Sorry, I follow the.
That's okay. When you build the unlocking transaction, oh, can everybody hear me? I'm sorry, I might be breaking up.
Yes, I hear you.
When you build the unlocking transaction, make sure that you're using txin datum file, where the file is the path to what you just showed me.
I did with a tx inline datum present.
Oh, that might be it. Now I'm unfamiliar with the file. Maybe they already gave you inline datum.
I send you with on the chat, but so I'm unlocking it with tx datum present. So
You are okay. Okay.
Yes.
All right. So it's locking fine. It might be. Yeah, okay. So this is definitely going to take more time than I have right now to troubleshoot because I don't understand the assignment yet. but another thing to look at, even after you get the datum right, sometimes understanding that you need two separate signatures here is going to be important. But I would have to read the assignment myself to be able to help right now.
It could take long, but see it later.
Yeah, I'm happy to look at that next week. If we want to use live coding Wednesday, Thursday to start with questions about this. And if you wanted to screen share, we can do that together.
Yeah, yes, it will be cool.
Cool. Cool. And it looks like Roberto's working through the same thing too. So yeah, if you guys have like insights about that in the chat over the next few days, I'll be curious. All right, cool. Well, thanks for letting me do a share like that today. It wasn't as interactive as other sessions, so hopefully we can keep it. I like the sessions where other folks are sharing and we're troubleshooting, but it felt like a good chance today to look to take Martin's question and really run with it. We haven't yet looked together at reference scripts. But we could give the same treatment, okay, to the difference between using a Plutus file versus using a reference script as we gave today to datum hashes versus inline datum. So keep that in mind as you look at the second mastery assignment. You're going to see a reference script in action, but as you have questions about how that works, just know that we're going to be looking at it together. All right. Going to stop the live stream, but stay on the call to work with Sebastian on some future lessons a little bit. So everybody's welcome to stick around. But if not, see you soon.